today with regards to grab sampling. Without further ado, let me introduce myself. I am Matt Dixon, as Sherry mentioned. I'm an application engineer in our custom solutions department back in the Swagelok factory, which is located near Cleveland, Ohio. So I'm in sunny Cleveland, Ohio today. So we're going to be talking a little bit about grab sampling. Let's first start off talking about what actually is grab sampling. So grab sampling, it goes by a lot of different names, sometimes called lab sampler or just sampler or field sampler, but it's really all about taking a sample out of your pipeline, out of your tank, out of your taking that sample out of your process and taking it to a remote laboratory for analysis. And there's a few different ways that you can do that, a few different types of sample containers, but we broadly break it down into two main styles of panels, either a cylinder style panel or a bottle style panel. And it's really, again, dependent on the type of sample container that you're going to be using. So why are we actually taking the sample? There's a lot of different reasons why we might want to take a sample out of our process. First of all, of course, is to verify that the process conditions that we think are in our process are actually what's going on. We need to verify that the product that we're producing meets the specifications, whether it's the end product that's going out the door, or whether it's the product that's moving from one part of the facility to another part of the facility. Another big reason is that we need to validate online analyzers. Analyzers are definitely kind of the gold standard for sampling. We want to get those results in real time, but at the same time, we need to make sure that those online analyzers are giving us actual results that are accurate. So we periodically need to take samples and verify and compare those to what the online analyzer is giving. And of course, anytime that we have a change of custody, so if we're offloading from a ship to the onshore facility or vice versa, or going from a facility to a pipeline, you very often need to have a reference sample that's taken for by grab sampling. Sometimes you analyze that sample, sometimes you don't. Sometimes you just leave it on the shelf for analysis later on in case something goes wrong. But you generally need to have a sample taken in those types of situations. And of course, environmental regulations. Those tend to get implemented and not retracted very much. So as we go further and further, generally those regulations increase more and more. And so we need to be able to take samples. One, to make sure that take samples from our flue gases to make sure that we're not releasing anything to the environment that's detrimental to the environment from our facility. But then also testing the product, for example, testing the mercury content in gasoline as an example, just to make sure that when that product is used later on, it's not going to be contributing negatively to the environment. So lots of different reasons why you might use grab sampling. In addition to that, there's a lot of different places within your facility where you're going to actually be performing grab sampling. Certainly in storage locations, whether it's a tank farm, incoming or outgoing. Anytime you have long transportation lines where you could potentially have some product changes, you might see that within the facility, the process lines. And of course, we already mentioned the flare and the environmental aspects. So you could be testing those flare gases, testing whatever's coming out of the flare. And then we already mentioned the process analyzers. And what is it about, are those process analyzers, giving us true readings? Because we really need to make sure that that's happening. So we've mentioned process analyzers a couple different times right now already. So what are the differences between those two things? So grab sampling, there's a lot of advantages to grab sampling, but there are also some drawbacks when we're comparing these two different sampling methods. So first of all, grab sampling is a lot less expensive, at least initially, from an installation perspective. All right, so a grab sample panel itself is relatively inexpensive compared to the analyzer, compared to the sample conditioning system of that analyzer. So there's a lot of advantages from an initial capital investment perspective. It's also easier to install. One of the main reasons is that it's smaller and can be put a lot closer to the process itself. If you think about an online analyzer, Typically, that's not something that you can install right next to the process. That needs to be installed in some sort of a shelter, typically some sort of an analyzer shelter that, relatively large. It could be 20 feet by 40 feet, a little building. And, where do you have in your facility that you can locate that? Chances are it's not right next to the sample point where you want to take that sample. So you've got to locate that building some distance away. And then installing that, of course, with all the utilities, the HVAC, all of that's a huge expense. And not to mention the fact that you now have to run the tubing from that sample point all the way over to wherever that building happens to be installed. Whereas a grab sample panel, relatively small, just a few feet in dimension. So it really can be sandwiched in most anywhere within your facility. So you can generally put it really close to the process as long as it's a place where the operator can get to it. Another advantage of the grab sampling is that analysis is actually happening in the laboratory itself as opposed to distributed throughout your facility. So as a result, you're able to concentrate your expertise in the laboratory instead of having those technicians, those analyzer techs, going all around the facility and having to maintain those in this distributed fashion. It's all concentrated in one location. Now, of course, there are some drawbacks to the grab sampling operations when compared to the online analyzers. Of course, the biggest one is time delay, right? So with an online analyzer, the gold standard is to get your sample from the process pipe to your analyzer in 1 minute. So you have at that point essentially real-time results. You can monitor what your process is doing, based on those results coming out of your analyzer, and you can make real-time process corrections if you need to. With a grab sample, it's not the case, right? So you take samples, you send an operator out into the field to go get samples, but they're not going out to just get one. They're typically going out to get samples from a half dozen or a dozen different sampling locations. So they're riding around the facility, they take the sample, they go around to the next 6 or 7 or 8 or however many different sample points to collect those samples. Maybe an hour or two later, they finally make it back to the laboratory, and those samples sit in queue because they don't get analyzed right away. You can't, so they sit in queue, and maybe a few hours later, that sample finally gets analyzed. And if you find something that's out of specification, now you've run a few hours or 6 hours or 12 hours or however long of bad product through your pipeline. So having those real-time results that an online analyzer can give you is definitely an advantage over grab sampling. Another disadvantage of grab sampling is that it is harder to maintain that sample at the process conditions. As we'll discuss in just a little bit, one of the main considerations when we're looking at sampling is to maintain that sample in the appropriate condition. We don't want things to start changing phases on us and things of that nature. So maintaining gases as a gas and liquids as a liquid is definitely a priority for us. And it's definitely much harder to do with a grab sample because, again, you have that time element where you can have different temperature fluctuations, and you also have just the fact that you have to transport this thing around. And so there's a lot of different opportunities for things to go wrong as compared to an online analyzer. It's also potentially more dangerous. Just by its nature with the grab sampling, you're introducing the human element because you have a person that has to physically go in and interact with the process fluid. So you're dispensing the process fluid, whether it's into a sample cylinder or into a glass bottle or whatever that sample container is. But by its nature, you have an operator that goes up and has to turn valves and is right there when that process fluid comes out. So just by its nature, you introduce the human element, which makes it more likely for something to go wrong. But at the same time, just by their presence, it makes the consequences of something going wrong much, much higher. So definitely a disadvantage there from a grab sampling standpoint. And then also, we've seen instances where customers are not properly cleaning their sample containers. After they're done taking a sample, that container really needs to be properly cleaned, whether it's a cylinder or a bottle, before the next sample is collected. If not, then that previous sample can actually, bits of it can still remain in there and contaminate the next sample. So if that's not done well, then you could potentially have some purity issues. All right, so let's talk a little bit about some of the different basics that we talk about when we're looking at sampling system design. So a few different ideas, a few different concepts. We like to say that we want our sample to be representative, timely, and pure. So what do we mean by that? We want that sample to be representative, meaning that it must be the same as whatever it is that's flowing through that process pipeline or coming out of or that's actually stored in that tank. So we want to make sure that we're avoiding phase changes, for example. Again, phase changes can really fundamentally change your sample, so it's really something to be avoided. We also want to use probes when we're taking a sample out of a pipeline. Your most representative sample is going to be collected at the center of that pipeline where you have that flow. Collecting a sample from the wall of a pipeline, you're not necessarily going to get the most representative sample of what's flowing through there. In addition to that, you're much more likely to get contamination and things of that nature. So we generally want to use probes when we're taking a sample. We also want that sample to be timely. With grab sampling, again, it's not as important to get that sample from the process pipeline to your grab sample panel in that 1 minute gold standard that we talked about for online analyzers. It's not as important, but we do need to understand it. A poorly designed system can literally take weeks to get a sample from the process pipe to the grab sample panel. So if it's not done well, you could be taking a sample and not realizing that your sample is representative of your process 3 weeks ago. So you really need to understand that. And then also, we've already touched on the purity a little bit. We need to make sure that we're not contaminating our sample. We want to make sure that the sample, again, is representative of the current process and not being contaminated by the old one. So we do things like avoiding dead legs. So dead legs, if you're not familiar with the concept, with dead legs, imagine you have a system here. A dead leg is a point in your system where you're not actually flowing. So imagine you have your sampling system where we have a sample container that's off the screen down below here. And we have our sample flow coming in the top and flowing down. And notice we're flowing past 2 T's. We've got one T that has a gauge on it here, and we've got another T that goes to a bypass valve. Well, those 2 T's have these branches here in red that filled up with fluid at some point during the process. But how old is that fluid? There's no flow in this, right? So there's nothing flushing through and flushing out this old fluid. And as this new fluid is going past, molecules are coming out of this branch and just slowly contaminating that stream as it goes by. So that's what we would call a dead leg. It's an area of no flow that's potentially contaminating your sample process. So we avoid these things wherever we can. For example, we would want to put any gauges we would want to put on the downstream side of the sample container where it's not going to affect anything. So those are the types of things that we do is we make sure that if there are any dead legs, one, they're minimized altogether, but two, if we have to have them, that they are on the downstream side of our sample container where it's not going to affect our sampling operation. We also want to make sure that our process is able to be purged or flushed out if need be. And again, using those clean sample containers is another area that helps us to maintain that purity. Now, so those are some of the basic concepts, but we also have to understand what it is that we're sampling as well. So when we're sampling something, we need to understand the characteristics of that fluid, both in its temperature and its pressure and how it's going to behave in changes. We need to understand whether it's a liquid or a gas, of course. Liquid is going to be incompressible where a gas is not. A gas can be compressed. We also need to, again, understand how the changes in the temperature are going to affect our sample. So we need to pay attention to the phase diagram of the components of our sample. So we've got the different components. Chances are when we're sampling something, it's going to be a mixture of various components, whether it's hydrocarbons or whatever else we're sampling. So we need to understand all the different things that are mixed together and look at the different phase diagrams for those different components so that we can understand what's going to happen when we increase the temperature or vice versa. So in general, when we increase the temperature or decrease the pressure, we're much more likely for the light components to start vaporizing or boiling out of a liquid. So if we have a liquid that has methane dissolved in it, for example, and then we start increasing the temperature or dropping the pressure, it's very likely that that methane is going to start to bubble out. Very much the same as when you open up a can of soda, and now all of a sudden you've decreased the pressure, and all that carbon dioxide that's been dissolved in the liquid all of a sudden starts rushing out of it. Same thing can happen with our sampling container. So that's why we want to maintain that sample at the process conditions where we can, because we don't want all those light components, that methane, or in the case of the soda, that carbon dioxide to come out of our sample, because once that happens, now we fundamentally changed our sample and we can't get it back. So we need to understand how that change in temperature is going to happen, and if or is going to impact us. Conversely, the opposite can happen with gases as well. So if we decrease the temperature or increase the pressure on a gas, we can actually start to condense out some of the heavier components that are vaporized in that gas. We can start to condense that into liquid. So definitely need to understand how that's going to affect us. And we really do need to avoid those phase changes. If that phase change happens in the sample container, it's probably not the end of the world. We can probably get it back to where it was, or pretty close. But if that phase change happens in a moving transport line, it's done. You've lost the purity of or the representativeness of that sample, and you can really never get it back. So you really need to pay attention to those things when we're looking at our sampling system design. So depending on whether that's going to be a gas or a liquid, that's really going to push us towards one type of a sample container or another. So again, the ultimate choice generally comes down between one of two things, either a bottle of some sort, and whether that's a glass bottle like what's shown here, or whether that's a metal can or some sort of a container that's really just not intended to be pressure containing, or you have a sample cylinder assembly, which you see there at the bottom of the screen. Sample cylinder assembly like that, that's going to be able to maintain pressure. So what are the deciding factors? Cost, of course, is always a big one. This glass bottle, as you might imagine, is quite a bit less expensive than a sample cylinder assembly. So in general, if we can, we're going to use a glass bottle where it makes sense. But there are definitely some limitations with that. So for example, our pressure. This bottle is really not intended to be pressure containing. Maybe you could get a few PSI out of it, but you're not going to get 100 PSI out of it, that's for sure. In general, a bottle just really, you should not plan on putting any pressure whatsoever into a bottle. So if you have to maintain your sample at a pressure, like a gas, for example, or it's a gas that you want to keep from, or sorry, a liquid that you want to keep from vaporizing, in that case, you really do need to have a sample cylinder. Toxicity is another reason. With a bottle, you are really risking exposure to the operator much more so than with a sample cylinder assembly. A sample cylinder with quick connects on it and a proper purge system, you can really handle toxic samples very, very well. Whereas a bottle with a toxic fluid in it, yeah, you can have rubber septa and things of that nature, but just the seal integrity is just not there compared to what you would get with a sample cylinder. And then we talked a little bit about the sample volatility already. If you have a volatile sample, a volatile liquid that wants to change from a liquid to a gas, you really do need to have a sample cylinder so that you can hold it under pressure and keep it from making that phase change. So those are some of the considerations that we have for taking a sample in either a bottle or in a cylinder. So let's take a look at an example. Most of you probably recognize what we have here on the left. This would be a distillation tower or distillation column in a refinery. So the basic process in the refinery, of course, is you boil the crude oil and you vaporize most of it. And so you have the hot gases coming up, and at different levels of the tower, you get cooler and cooler as you go up. And so at different levels of the tower, you're recondensing some of those different products. So at the bottom end, you get out some of the heavier components, the heavy oils. At the top, you end up with some of the light gases that never actually recondense, some of your methanes perhaps, or your LPGs. So those are pretty much always going to be gas under normal atmospheric conditions. Down at the bottom, you'll have those heavy liquids. They're always going to be liquids under atmospheric conditions. But here in the middle, we have these volatile liquids. These are the ones where we need to take a closer look to decide whether we're going to take a sample with a bottle, like we would with a liquid, or whether we have to use a sample cylinder, like we would with a gas sample. So let's take a little bit closer look at that. So here, these are a number of different hydrocarbons that we might expect to see coming out of a distillation tower. So let's take a look at this pentane here. So pentane has a boiling point of 36C. Again, we're looking at the volatility of the sample. And so when we're talking about the volatility of the sample and whether or not we can use a glass bottle or a bottle to take a sample, in general, what we're looking at is the boiling point. At my atmospheric conditions, is this sample going to boil? Is it going to want to vaporize away? And so with pentane, we can see here the boiling point is 36C, which that's whatever 90 something degrees Fahrenheit. So even here in Cleveland, we occasionally get to 90 something degrees Fahrenheit. So we would consider that to be a volatile sample. Compare that to hexane, the one below it, 69 degrees C. Okay, that's quite a bit warmer. It definitely doesn't get up to 69 degrees C here or anywhere else on this planet. So I think that's pretty safe to say that is a non-volatile sample. So that's about where we would draw the line here. So between hexane and pentane, that's a good place to draw that line. So anything below that, we could pretty safely take a sample in a bottle and not have to worry too much about that sample changing phase on us. Whereas up above, anything above that line, that's where we need to worry about containing that sample a little bit better. And so in that case, we would probably want to use a sample cylinder. Now, there's nothing saying that you couldn't use a sample cylinder for these down below if there was another reason to do so. So toxicity, again, the toxicity of the sample plays a big role in that. So if you have a toxic sample, you don't want to expose the operator, excellent reason for using a sample cylinder. So in general, you can use a sample cylinder to sample any of these, but really can only use a bottle below the line. Above that line, now you've got those volatile samples, and the bottle just really isn't equipped to be able to contain a volatile sample. All right. So now that we understand some of the design characteristics, along with some of the decision factors in terms of bottles versus cylinders, let's take a look at some of the standard designs, some of what we consider at Swagelok to be the best practices for sampling. So let's take a look first at our cylinder style panels, what we call our grab sample module or GSM. So these GSM panels, they all have this one thing in common, which is a geared valve assembly. And it's either a 2-valve assembly like you see here or a 3-valve assembly. And what this does is it allows us to have a simplified interface for the operator. Rather than have the operator have to sequence different valves and different things of that nature, really all they have to do is turn this one handle to one of 3 different positions, either sample, off, or vent. It'll operate all 3 of these valves all at the same time. And so based off of the clocking of those valves and the drilling and the balls of those valves, we get exactly the function that we're looking for every time. So really simplifies things for the operator, makes it easy, and really cuts down on some of those errors and potential for danger that we had talked about previously. A lot of different options. So we've got 2 basic standard flow paths. We've got one we call standard, another we call continuous flow. We've got panels for both liquid and gas. So it depends on, again, the phase of the sample that you're taking. We can add a purge if we want to. So if you have a sample that is, again, toxic, or if you have a sample that maybe it's a liquid that's going to solidify if we allow it to sit in the line and cool down. So we have a purge option to get rid of that remaining fluid in the line. Got different cylinder sizes that are available, different styles of quick connects, optional relief valves, lots of different options that we have here. And of course, we have the ability through our custom solutions department back at the factory and also locally at Swagelok, Indiana, Cincinnati, to be able to customize these in any way that you might want. So let's take a look at the difference between what's going to be the difference between a liquid panel and a gas panel. So again, these are cylinder panels, so they could be used for each, but in general, they're very similar, whether it's liquid or gas, just a few minor changes. First of all, on the liquid panels, you'll notice that we actually fill from the bottom up. So that allows the flow to come in and the fills from the bottom up, and any gas that happens to be in that cylinder can then escape out the top as we're filling it. If we filled from the top down, we would just be basically dripping through here, and it's very difficult to tell how much liquid you would actually end up with in that cylinder because of the gas that's currently in there when you first start out with that sampling operation. Conversely, with the gas panel, we actually fill from the top down, and that allows any condensation that's in that line to get flushed out. So if you have any condensation in the line, it'll just fall to the bottom here as you're filling, and that gas stream will just carry it away. However, if you're filling from the bottom up, then essentially the cylinder itself could potentially fill with condensate from that gas stream. So liquids, we're going to fill from the bottom up. Gases, we're going to fill from the bottom down. And you'll notice that we're always going to have any sort of relief valve or pressure gauge, or even our hose is going to be on the downstream side of that cylinder. So on the liquid one, it's on the top side because that's the downstream side of the cylinder. On the gas one, it's on the bottom side because, again, that's on the downstream side. Again, we're trying to avoid those dead legs, those things that could potentially compromise our sample's integrity. So let's take a look at one of these. Well, actually, first, let's take a look at the part numbering structure. This is kind of unique to Swagelok's grab sampling offering, and that we do offer a part numbering structure. So a smart part numbering structure that allows you to fully specify, a sampling panel. So, you can make all your different selections, and and make sure that same selection, if you have multiple installations, you can specify a particular part number across multiple installations and know that it's going to be the same across all of them. Even if you want some customizations, this is just a great communication tool that you can use to work with us. Say, hey, I want this panel number XYZ, and I want these few modifications. And whether those modifications are simple, maybe it's, hey, you've got a 2.5-inch gauge on here, and my plant standard is 4-inch gauges. So, okay, we can make that change. Or maybe it's something completely different. We have that ability to customize. Let's take a look at a standard panel here. So this one's pretty simple, pretty straightforward. So this one's going to be a liquid panel. So again, we're going to fill from the bottom up. And first thing we're going to do is we're going to turn our geared valve to the sample position. And notice this one is a 2-valve geared assembly. So it's just the 2 valves. And once we fill up our sample, it just flows on through and goes to the outlet. We can go to the off position, and that flow stops. The flow does not go through from the inlet to the outlet. Got our sample in our sample cylinder. So we can go ahead and close the valves on our sample cylinder. So now we've got the sample isolated in our cylinder. Now we can go to the vent position, and that relieves the pressure on both sides of the cylinder. So now there's no pressure on those quick connects. We can go ahead and disconnect them and take this cylinder off to the lab for analysis. Now let's take a look at another one. This one's a little bit more complicated, but still pretty straightforward. So this one is a gas system. And in this particular system, we've got a continuous flow. So this, instead of our standard flow path, this is our continuous flow path, flow path. And what that does is it actually adds a 3rd valve to our geared valve assembly. And so now we always have flow from the inlet to the outlet no matter what. So always, this might be a good application if you had, a fast loop where you don't want to stop the flow of the fast loop. So this could be a good option for that, or a few different applications as well. And here we've also actually introduced a purge. So with this one, we'll be able to use that purge to remove all of the excess sample fluid from the panel after we're done. So let's see how this one works. So first, we're going to go to the sample position. And again, because we're a gas, we're filling from the top down. We're flowing through our sample cylinder from the inlet to the outlet. Next, we go to the off position, and our inlet is still flowing from the inlet to the outlet because we've switched this valve at this point, but we're not actually flowing through the panel itself. Our purge, by the way, is shut off still. Then we go ahead and isolate our sample in our sample cylinder. So now we've got an isolated sample cylinder. We go to the vent position. So now we've vented the pressure. And then finally, we turn on our purge. And so now the purge flows through and sweeps the system clean. And you'll also notice that that purge is actually going through the quick connects themselves. So now, as you're probably aware, when you disconnect a quick connect, even with the valved quick connects, you do just get a small amount of spillage. So now when you disconnect that quick connect, it's going to be what's going to be spilling? It's going to be the purge fluid. It's not going to be that sample fluid. So the fractions of a milliliter of spillage that you get with any quick connect when you disconnect, in this case, it's going to be the purge fluid. Now that could be very important if you had something that was toxic, right? You don't even those small amounts for something that's ppm levels of toxicity, you definitely don't want to release that to the atmosphere, especially around the operator who's disconnecting that. So definitely an option that we recommend for toxic samples. Of course, to go along with cylinder style panels, we do actually sell the cylinders, of course, the cylinder assemblies. It's worth noting that they are sold separately. And the reason we do that is because it's generally not a one-to-one relationship. It can be, but very often you have multiple sample cylinders to one panel, or vice versa, one sample cylinder that's used on multiple different sample collection points around the facility. So rather than addressing that, we just said, let's just separate those out. They're purchased separately. It just makes life easier. All right. So the GSC, the grab sample cylinder, again, has the same basic options to mirror the options that are in the grab sample cylinder, or sorry, the GSM panels. So the same size as same sizes of cylinders, the same materials of construction, valve options, quick connect options, lots of different options there in order to specify exactly what you need for that sample cylinder assembly. We also have GSL panels. So this would be our grab sample for liquid. And again, these would be our bottle style panels. So in the case where we are sampling in a bottle, again, that's always going to be a liquid, a non-volatile liquid. So that's where that name GSL, or grab sample liquid, comes from. Again, we've got lots of different options here. 7 different standard flow paths, different options in terms of whether you want a cooler or not. Different needle styles for those of you who are actually using a septum on the top of your bottle. So lots of different product features that we have there available to us. And of course, as with the other panels and as with the sample cylinders themselves, we have that ability to customize. We can make the panels as customized as you want them to be. And we can go through actually some of those examples of that customization here in just a little bit. So let's take a look at one example for the grab sample for the GSL. That is our flow path number 6. And this one is actually a fixed volume sampler. With a fixed volume sampler, rather than having the operator having to dispense a certain amount into the container and then stopping when they've actually dispensed the proper amount, with the fixed volume sampler, it actually pre-measures out an amount of fluid, generally equal to about 60 to 80% of your bottle capacity. So it measures that out, and then you actually use a purge gas to transfer that liquid into your sample container, into your sample bottle. So let's take a look and see how that works. So again, in this particular panel, we're again using that geared valve assembly. So we've got the 2 valves here, and when we first start out, nothing much is happening. We've got our inlet that's shut off. We've got our purge gas that's shut off. So then we go to the flush position, and that allows the liquid to flow through, and it flows through this guy right here. And this is what we call our fixed volume chamber. So this fixed volume chamber is, again, that thing that's on the panel that's pre-measuring out that amount of liquid that we're going to dispense into our sample. And again, that has to be sized to the size of bottle that we're going to use, because we want to, again, size 60 to 80% fill on that bottle. So now that we've got that fixed volume chamber full, so we've let that fluid flush through here, so we've got a good representative sample in our fixed volume chamber. Now we can go ahead and make the switch, turn on the sample, and now our purge fluid, in most cases nitrogen, pushes that liquid out of here and into our sample bottle down below. And then that purge gas then just goes off to the vent. So we've done 2 things with that purge gas. We've, one, used it to move that sample from our fixed volume, our fixed volume chamber on the panel into our sample container, and at the same time we're cleaning out the panel so we're ready next time we come to take a sample, we're ready with nice clean lines to start out with. Another nice advantage of a fixed volume sampler is that you are isolating this bottle from a potentially high process pressure. So if you have a high process pressure, you don't necessarily want to open the valve on your sampler and allow that flow to come blasting through into your bottle. However, with this one, as soon as we make that switch, this sample is really at the pressure of this purge gas. And that purge gas is at a nice low pressure. We're talking 10 psi or so. So really low pressure, because you don't need much pressure to transfer that sample. And so as a result, we got a nice gentle flow rate into our bottle. We don't have to worry about that high pressure. So we've essentially isolated our sample, our process pressure from our sample container. So that's another nice feature of this system.
Hey Matt, is there a pressure limit on the incoming pressure to a GSL? I know obviously when you get to the bottom you want to be atmospheric, but what would be the pressure limit without the fixed volume?
Yeah, so the this valve itself, the sampling valve itself, is I believe rated to 2200 psi. So that would be your absolute limit. Now, I think the general recommendation is that once you get to 1000 psi or above, then you start thinking about how do we isolate that pressure, whether that is through some sort of a regulator or a fixed volume sampler like this. That's when we start to think about that. Is it 1000 psi? Now, some people that threshold is a bit less. Maybe that's a few hundred psi for some people. But in general, I think we're pretty comfortable with up to 1000 psi, just because of the fact that this valve actually does have an orifice in it. So we're able to knock the pressure and flow rate down using that orifice rather than having to rely on throttling the valve.
Okay, thank you.
You're welcome. All right, so you might ask, what sort of documentation do we get with these sample panels? Well, first of all, probably the most important documentation is right on the panel itself, and that's the labeling, right? We need to make sure that everything is labeled appropriately so that the operator knows what to do. So all the valves are labeled, the gauges are labeled, and we also have then an engraved label plate that's just right there on the panel as well. So that label plate's going to have the operating instructions. It's typically going to have a schematic on there. So just helping the operator and anybody who might have to do maintenance on that panel, get them the information they need right at the place that they need it. Beyond that, of course, sales drawings. We create the sales drawings for these particular panels, along with bills of materials and potentially a spare parts list, whatever you need in order to satisfy your needs. So we're pretty flexible there in terms of documentation, but at a minimum, again, these are the types of things that you're going to get. Now, let's take a minute to talk about how these are produced. I'm here again at the Swagelok factory back in Cleveland, but we realize that Swagelok is a global organization, so we're not going to be able to supply all of the entire world with these grab sample panels very effectively from Cleveland. So as a result, we want to be able to supply these as close to you, as close to the customer as possible. So as a result, we've actually enabled our sales and service centers to be able to do this sort of work locally with a certification program. So we've actually developed a certification program that allows our distributors to quote and build those standard systems locally. And we provide them with some tools to make things go quickly. So configurable CAD files, bill of materials generators, different presentations and assembly instructions, things of that nature. So we're basically putting all these tools into our distributors' hands to enable them to do it. And beyond that, we're actually enabling them to make modifications. So our distributors have, I mentioned custom solutions before. It's a great way for us to customize these panels. Custom solutions is basically where we take the valves and fittings that Swagelok makes and we put them together into bigger and better things. Things like grab sample panels that we're looking at here today. So we've enabled our distributorships with certification programs to do tube bending and tube fitting assembly and threaded fitting assembly and basic wiring and things of that nature. so I think there are 40 some different certification programs in all. So we've enabled them to do that, all those things at the local level, so that they can provide you with the best possible service. And this is just another example of that. This certification program that allows our distributors, our sales and service centers, to be able to fabricate these at the local level, work with you to customize them or to produce just the standard versions.
Is now exiting.
So within that certification program, of course, we're teaching them about the product itself, but we wanted to give more of a detailed background information as well. So we wanted to be able to give them some sampling basics so that we understand and can make intelligent design decisions around these things, along with some advanced sampling concepts, teach them how to work with those tools that I mentioned before, teach them how to handle design changes, teach them all about the third-party products that we commonly encounter with grab sample panels, whether it's sample coolers or site flow indicators or things of that nature, so that all of our sales and service centers are reading basically from the same sheet of music when we're working with this. And that's another advantage that Swagelok has, is that because of this standardization for our global customers, it provides a great opportunity to have that standardization around the world for these particular panels. Can really be serviced in the local market. So we do lots of different things there, and that really enables our distributors, our sales and service centers who've been through this program, to provide those standards, but at the same time be able to provide custom systems. So as an example, here's a really simple customization that we can add to a grab sample cylinder. In this case, we've added a relief valve with an expansion chamber. So in a case where you want to have a relief device on our sample cylinder, but again, coming back to that example of a toxic gas, if you can't have a relief valve that vents the atmosphere when you have toxic gas, right? So in this case, we've got that outlet of that relief valve plumbed into a second sample cylinder. And so you'll be able to see if that relief valve popped off just by the pressure gauge. You'll be able to see it there. So just an example of a very simple custom solutions that we could do with our grab sample program. Or maybe you want that grab sample panel, that GSL panel, but you wanted an enclosure. Whether it's heated or not, maybe you just want to protect it or keep the sun off of it. Here's an example. Or maybe you do want it heated. So in this case, this one's in an enclosure, has a heater on it, and oh, by the way, the sample itself is a hot gas, and so we do need to cool that down before we put it into the sample container. So as a result, we have a cooler on here. This one in particular, I believe the customer did not have cooling water available to them. And so as a result, they asked for that to be done with I believe, instrument air. I think we were using to cool it. So we actually used a cold gun, a Venturi style cold gun, in order to generate a cold stream of air to cool down the incoming sample. Here's one where there was very low pressure. So as a result, we had to add a pump. So this one happened to be in a hazardous area, and so rather than introduce electrical into that hazardous area, we were able to use the instrument air supply in order to drive a pump with an air motor. So this again is a pump that you wouldn't necessarily have on continuously, just during the sampling operation, obviously with an air-driven pump, but it allowed us to get around that hazardous area classification problem without too much trouble. Or it could be something where we are looking for something completely off. So as an example, here we have a sampler that's custom designed for sampling of liquid ammonia. So it doesn't look much at all like the other grab sample panels that we've been looking at, but this is an example of how we can apply our sampling expertise, not to just the standards, but to really any sampling problem, whether it's an online analyzer or a grab sampling type of an operation. So really, in summary, there are a lot of different reasons, a lot of advantages of working with Swagelok on these. Certainly we have a really unparalleled design expertise when it comes to sampling systems, both with us and all the people with whom we have relationships, like Tony Waters, a renowned instrumentation and analytical instrumentation expert within the global scene. Certainly, we're already providing you and working with you on the component level. So, working with us on the sampler panel side of things is also a big advantage. And just the design of the panels themselves. We really think that we've hit on some best practices here with our panels. And so it makes it easy for them to operate, makes it sure that the sample that we're going to get is going to be representative, and of course safety. Safety is a big consideration for everybody. So the design of the panels is inherently safe, trying to make that as safe as possible for everybody. And again, lastly, I'll hit on that last point again, is that ability to work with our local sales and service center. So you're not necessarily working with me back in Cleveland, but you're working with your local sales and service center in Indianapolis or Cincinnati, and understanding that we can accomplish these things at the local level. We don't have to come back to the factory in Cleveland to do it. We can do it at the local level where you can see it being built. Where it's just a little bit more nimble and responsive than we would be. So, in summary, overall, we think that there's a lot of advantages to working with Swagelok, and we think that we take some of those design considerations and really put them into practice with our designs. So, at this point, I think that concludes the actual content. If you guys have any questions, I would be more than happy to answer any questions that you might have.
Hey, Matt, can you using a single panel, can you sample from different locations?
You can. Generally, in general, the economics aren't there. Again, because of the fact that these panels are relatively inexpensive, you generally don't want to do stream switching with them. It's not the ideal practice. It can be done, but in general, the cost of the stream selection and plumbing multiple points to a single panel overshadows the cost of just two individual panels. So it can be done, but it's generally not recommended.
Okay.
Matt, can you make these panels out of different materials like Monel, Hastelloy, things like that?
Yeah, absolutely. Most of the products that are on these panels are available in those materials. So whether it's exotic materials like Monel or Hastelloy, or whether it's coatings like a silk inert or NACE compliance, or whatever those different options that you might need, we can definitely accommodate those sorts of things.
And we actually have a question. What options do you have for sour gas applications in sample cylinders?
Yeah, good. So we do actually have sample cylinders that are qualified to NACE. So we have ones that are 316 that are qualified to NACE, but at the same time, we also do have Monel sample cylinders. So that is definitely one option, and of course, all the accessories that go along with that, the valves, the quick connects, etc. So for a sour gas panel, again, would depend on the concentration of the H2S, but maybe we're going to be going with a 316 panel that has the NACE certification on it, or depending, if it's a higher concentration, maybe we're just going to go right to the Monel components, and all of those components that you saw on those panels are available in Monel, so shouldn't be a problem there.
Okay.
It looks like we're getting a follow-up question there, Matt.
Okay.
Any options available for pyrophoric gases? And I hope I pronounced that correctly.
Yep, pyrophoric. Yeah, so pyrophoric, we actually, it's something we would definitely recommend of using a sample cylinder as opposed to a bottle. For those of you who aren't aware, a pyrophoric material is one that spontaneously combusts in atmosphere. So definitely something you don't want to have leaking for obvious reasons. So a bottle sampler, those we have heard of some customers doing that. It's definitely not something we would recommend. Definitely would go with the sample cylinder. So at that point, it's a question of chemical compatibility to the materials of construction. Pyrophorics tend to be somewhat reactive, obviously. So we want to make sure that the elastomers and the metals that we're using are compatible. So depending on the specific one, we would have to look at that for compatibility. And then we'd probably also recommend using a purge, because again, you do have just that small amount of release when you disconnect a quick connect. So you'd want to make sure that that's the purge gas being released to atmosphere and not the pyrophoric material.
As far as H2S concentration, when would you switch from a MACE to a Monel, or is there a gray area there?
Yeah, it's definitely a gray area. To be honest, I'm not really an expert in that particular area, the metallurgy and where that threshold really is. Yeah, I'd probably have to follow a metallurgist in order to see what the recommendation is.
Do we have any additional questions for Matt or any of our guests?
Looks like we got another one coming in right now.
Here, it just popped up on my screen. Is there any remote controlling available for sampling from Swagelok to avoid time delay?
Yeah, we can absolutely do some automation on the panels, if that's what you mean by remote controlling. We can, we can have the, whether that's controlled and you've taken samples on a periodic basis, or whether it's something where the operator actually has to go out in the field and maybe they just press a button and it automatically takes a sample. Lots of different automation options there, and the options are really limitless. So we can definitely customize that to whatever you need, whatever you're looking for. In terms of avoiding time delay, that's really more of a function of system design. So when we say time delay, we're really, when we're talking about that, we're talking about the time that it takes to get the sample from the process pipeline to the sampler. So in that case, it's really a function of the system design, not so much the automation. If you're specifically referring to the time delay as how much time does the operator have to spend out there, maybe a different definition there. But in that case, yes, we can absolutely do automation to reduce that amount of time that the operator has to interact. Maybe it's something that can be triggered remotely, and then the operator just goes out and picks up the sample, and it's already there waiting for them. So definitely options that we have there, whether it's a standalone system or integrated with your DCS. Lots of different things we can do there.